Good morning, everyone. My name's John Hodgson, and I'm about to present a video on Proxmox. It's going to be quite an extensive course from the bottom up, so from kind of zero to hero, if I can use that overused expression. I have about 40 years experience of working with Unix and Linux, and also about 5 years experience working with Proxmox. I've done a large project, actually migrating a very large VMware farm from VMware across to a Proxmox cluster of 6 HP Reliant servers. And it was great fun, a huge learning experience, and I still help maintain that cluster to this day. So I have some sort of background in this topic. Not claiming to be the world's best expert, but I think I can at the very least give you an extremely good in-depth introduction to this topic. So what are we going to cover? Well, I've come up with a list of topics which may vary slightly as we go through the session, but basically this is what I've come up with. So the first session is going to be an introduction to Proxmox and a demo of an existing cluster that I've built. And then I hope, as long as the first section doesn't last too long, to also do an installation of Proxmox and sort of initial configuration and setup. And then I won't read the rest out to you because I'm sure you can read. But basically we're then going to cover pretty much every aspect of a Proxmox environment, including at some point we're going to look at creating a Proxmox backup server. But I won't do that until right towards the end. But that's another really nice feature of Proxmox, is that they provide a software solution for your backups and for snapshots, incremental backups, full backups, recovery. Obviously, it wouldn't be a lot of use if it was just backups, and we will cover that. Thank you for listening, and let's get on with the course. Okay, so let's start by talking about exactly what Proxmox is. Proxmox is a piece of software that allows you to use the hypervisor to run virtual machines. So in an ideal world, you have a machine that has Proxmox running on it, which by the way is Linux based and open source. And it allows you to create, depending on the resources available, how many cores, how many threads per core, etc. It allows you to actually create virtual machines up to the amount of memory you have, and of course storage, etc., which would be limitations in just how many you could create. So first of all, let's have a quick run through, an overview of what Proxmox is and what its components are. All right, so Proxmox is actually open source, so that's really good. It's free and it's open source. There is actually a support package that you can buy, but there is no limited functionality in the free version. Annoyingly, it comes up and keeps reminding you that you haven't bought a subscription, but we can live with that. And in fact, there is a hack to stop it doing that, but I'm not going to go there. I'm not interested in that. So if you're familiar with VMware, I mean, it seems to be the kind of hypervisor that most people are familiar with, then Proxmox is very similar. Some people actually prefer it to VMware in terms of functionality, but let's just say it's very similar. Proxmox is actually licensed under the GNU public license, so that's good because it means it's free at the moment and it will always be free. Let's have a look at the most basic environment that you could create. This wouldn't be recommended, by the way, because this environment that we're looking at here is not highly available. If you had a problem with that server, then the whole thing would go down. So it's not exactly resilient in any way. But basically, this is an example of something we could set up, although actually I'd prefer to set up something more complex than this. But it's a single machine. It's running Proxmox virtual environment, which is running on Debian Linux. Okay, so it's Debian based. Ubuntu is Debian based, by the way. So if you do play with Linux at all, and if you've used Ubuntu, then the underlying distribution of Linux for Ubuntu is actually Debian. In this example here, we've got an extremely simple example, a single machine running the Proxmox virtual environment, okay, and it's got a couple of VMs running on it. So we've got a couple of VMs running. The storage that it's using is local to that node. So this is a very simple example of what you might see. Now, in the real world, it's going to look far more like this. And this is a clustered environment, okay? So I've given you an example here of 5 nodes in a cluster, possibly 6 if you look at my slightly grayed out one. And here we've got distributed storage, which is what you would almost always use in a production or commercial environment. So we've got a SAN, a storage array network, and this is where our virtual machines, virtual disks and virtual memory in the event of a machine being migrated or failed over. So the storage is visible to all nodes in the cluster, and this is going to be really important. We'll talk about it in more detail later. So the actual hardware, the machines, the physical machines, and in this example there are 5 physical machines, node 0 through node 4. The physical machines do not store directly the virtual disks of the virtual machines, okay? You can run as many virtual machines on a particular node as that node can support in terms of memory and other resources, CPU capacity, etc. But bear in mind that whole idea of this is if one of these machines fails, then the virtual machines running on that particular node are migrated across, or can be, depending how you configure it, can be automatically migrated across to other nodes in the cluster. So one normally doesn't actually create enough virtual machines on each node to fully utilize all of their capacity, because if you did that, there would be no space for migration from a failed node. Something that isn't really clear from this drawing, which is really useful and powerful aspect of Proxmox, is the fact that the cluster configuration is stored on every node in the cluster. When a node joins the cluster, it gets a copy of absolutely everything to do with that cluster. So each node knows everything it needs to know about the entire cluster. If we make a change to the configuration, if we add a new virtual machine or just change some basic configuration option, then all of the nodes in the cluster are updated. This is really neat because it means in the event of a failed node, which can happen, obviously, this is hardware and, you know, life happens. In the event of a node failing, all we actually need to do is replace its hardware or repair its hardware, and then simply rejoin it to the cluster. And in rejoining it to the cluster, it will actually then be given all of the cluster configuration information as part of that joining process. So it's really neat, and it makes it also very scalable. So for instance, in my diagram, node 5 could be added to our 5-node cluster, making it a 6-node cluster. All we actually need to do, and it really is this simple, it's absolutely brilliant, and we'll do this because we're going to do practical stuff in this session. All we actually need to do is install PVE, and PVE, by the way, is a complete installation. We don't have to install Debian Linux and then install Proxmox on top of it, although you can do that, but I would not recommend it. All we need to do is install Proxmox virtual environment and then join it to the cluster, and that's it. It's now a member of the cluster. We can start moving virtual machines across to that new node or creating new virtual machines. So now let's start actually having a look at what we're going to do through this course. This is my plan. My plan is to start off by giving you a quick demonstration of an existing cluster that I have already built and that is up and running. And then subsequently, we're going to actually build a 3-node cluster. Okay, why a 3-node cluster? Because I happen to have 3 machines that I can use. I could actually go more than that, but I don't see the point. I've actually got a lot of little mini PCs that I use for experimentation and learning purposes. So we will build a 3-node cluster, We'll build it one node at a time, obviously, and then we can join those nodes to the cluster. We'll then build 3 virtual machines, one for each node, or possibly more. We'll see how it goes, see how I feel on the day. And then I'll demonstrate things like migrating those nodes across from those virtual machines across from one node to another. And we can also demonstrate HA. That's high availability. So for instance, we can put a couple of machines on one node and then deliberately fail that node and see what happens. Now, you'll notice that the setup that I'm suggesting shows a home network, a single home network. In a production environment, we'd probably have that actually balanced across 2 physical network connections on the same network for resilience. But I've got a relatively simple environment here where I am. So we just have a single connection to a kind of public network, in other words, my home network. But I also have an NFS server. So I've got an Ubuntu-based server that is providing the storage for those 3 nodes. So they will have shared storage. The advantages of having shared storages is one, if you migrate, for instance, if you migrated Firebird, the virtual machine called Firebird on Mustang, across to Transam, if you weren't using shared storage, then you would actually need to copy all of Firebird's data physically across the network to be stored on Transam, which would take time and could be a really noticeable amount of time in the event that Firebird actually has a lot of data if it's a large environment. So that's not ideal. I mean, it would be fine, but it's not ideal. So by using an NFS server, and then that allows us to have the data available on all nodes. So if I migrate Firebird from Mustang to Transam, then Transam immediately has access to Firebird's disks. And it's really impressive just how quickly Firebird would actually boot up. So that's the basic setup that we're going to be using, okay? 3 machines, we'll build them one at a time. I won't bore you by going through building each one of them, but we will build one in detail. Then I'll quickly build another one for you, and then we will see how we join Mustang and Transam, for instance, into a new cluster. So we create a cluster and join those 2 machines. Then I'll build the 3rd node, and then again we'll join those to the existing cluster. So we will end up with a 3-node cluster. Exciting stuff. I think you'll enjoy this. It's when I first started getting it, I mean, I'd never even heard of Proxmox. I was in a meeting and somebody said, why don't we consider using Proxmox? And I thought, what's that? Sounds like some sort of detergent powder or something. In fact, I keep meaning to go away and find out what the hell it stands for. I might well insert a bit in this video if I find out. But it sounds like a horrible disease. But anyway, it isn't. It's really cool, really interesting, and I think you're going to enjoy this video. Hi, an interrupt from the future. As soon as I'd mentioned the fact that I didn't know where the name came from, I couldn't resist going and actually checking. And it turns out to be very simple and incredibly common actually on the internet. So here's the answer. The reason is simply that Proxmox.com was available. Wow. Okay, I'll continue. It's all right. Hang on. The light has just fell off the ceiling. How about that then? Anyway, it isn't uncommon that people search for a name that isn't in use. It doesn't really explain how on earth he came up with Proxmox, but still, there you go. That's the reason. Cheers. Now we've been introduced to the basic concepts of Proxmox. Let's actually look at a real example of a Proxmox cluster, and let's fill in loads of little details. There are always little details that need filling in. So first of all, let's look at what we're going to see. This is the diagram that we looked at earlier on. Actually, there was a typo on the diagram earlier on. I actually had Corvette on there twice. Right, so what we need to do now is take a look at the web GUI interface, which is in green at the top of the screen in this diagram, and notice that it appears to be available on every server in the cluster, and in fact that is the case. So instead of having a single administrative server, in other words, a single box that you logged into to look after the cluster, you can log on to any one of those machines. It's simply not a problem. Choose one and log in, and it's identical. Okay, which is really cool, because if you lose your administrative server, you've got to fix that before you can then continue to administrate your cluster. In this case, if we lost one server, it isn't an issue because we've got two others that we can run the administrative interface from. It's a web-based GUI, and we'll see it in a second, but I also wanted to remind you about the fact that the configuration is distributed across, in my example there, across 3 nodes. Now, by that, I don't mean it's shared between the 3 nodes. I mean there is a complete self-contained copy of everything you need to know on every node. And every node, in the event of a change, no matter where the change is made, which server the change is made on, every node gets an update of that change. Now, this does actually introduce a potential issue, which is that if you had a 2-node cluster, which is highly not recommended, if you had a 2-node cluster and you lost one of them went down, okay, then the problem you've got is that, well, has it gone down? So for instance, if we had Mustang and Trans Am, if Trans Am suddenly disappeared, so Mustang couldn't see him, the problem in his mind would be, well, is Trans Am down, or is it just that I can't speak to him? And in fact, the worst case scenario is that it's actually a network failure between those 2 servers. So Mustang would think, oh, I'm the only guy in the cluster because the other guy's broken. And Trans Am would think, oh, I'm the only guy in the cluster because the other guy is broken. And this is known as split brain. Okay, but for whatever reason, if you do not have more than 50% of your servers up and running, then what we would call that a non-quorum state, which we're going to talk about in a second. And if you had not more than 50% of servers running, then you would not be able to make any configuration changes to your cluster. So you can see that the quorum mechanism is a safety mechanism. We have to have a majority vote to be able to allow changes to take place. If a server breaks and it's taken out of the cluster, it can be repaired, and then if Proxmox is fine, but the server hardware is broken, we'd simply fix the hardware, reboot the server, and it would rejoin the cluster automatically, and its configuration would be brought up to date. In the event of Proxmox being completely stuffed, for want of a better term, then we would reinstall Charger. Then we would have to rejoin it to the cluster, okay, because our reinstallation would not contain in its configuration the cluster joining information. Okay, so that's fine. That's a quorum, and I'm sure we'll talk about it later on, and we'll demonstrate a failure of quorum and exactly what happens as we go through the course. Well, I hope you found that brief introduction useful and interesting. So what we're going to do now is actually look at the web user interface. Now, I deliberately don't plan to go into too much detail because otherwise we will just get bogged down in detail, and I really don't want that. So initially, I just want to take you through the GUI, show you roughly how it works, the format of the GUI, etc. And then we're going to actually create a cluster. I actually have a cluster already created. Previously we had a 3-node cluster. I have to apologize, it is now 4 nodes because I was doing some kind of analysis of a problem on another Proxmox cluster which had an even number of nodes, and we were trying to determine the behavior if an entire site went down of the remaining half of the cluster, which we we kind of know. I mean, we already know, but we wanted to confirm exactly what would happen. It was really interesting, actually. Maybe we could do the same. So we'll probably build a 4-node cluster, despite the fact that I said we'd build a 3-node one. Okay, so let's have a look at the actual web user interface. So notice, oh, by the way, when you install Proxmox, it actually, when it reboots, it actually comes up with a login prompt. And in a text-based console, CLI, but it tells you how to log into the GUI, and it's always IP address :8006, although you can reconfigure that to be a different port if that port is not appropriate for you. And when you go to that, oh, by the way, important point, if you put in HTTP 192.168.0.230:8006, it will simply say the site is unreachable. It has to be HTTPS, and I don't fully understand why they don't actually redirect from HTTP to HTTPS, but it doesn't matter. But of course, it can really catch you out. If you just put the IP address in, some of the older browsers anyway would actually try HTTP first, then you'd get this error. So been there, done that. Right, so let me log in. Now notice this is the login window. Root is the username. You would normally have to type that in, but I have previously logged in and used this cluster. So I ticked on save username. So I'm logging in as root. We will see later in the course, not in this session, that we can create users who have different privileges. So sort of we've got basically role-based access, so we can allow users to access certain virtual machines but not others. We can allow them to install new virtual machines or not, etc., etc. You can imagine the granularity is very good. So I'm now going to log in. So I'm logging in as root with the relevant password. I think the batteries are going flat on my keyboard because it's, if I type too quickly, I lose the odd character. Okay, I have actually increased the size of this, the actual text, because the default is, it is really quite small. So if you were looking on a laptop or something, then you typically need to expand the size, otherwise it's almost impossible to read it. Okay, so we have 3 columns here, and what I want to do today is give you an introduction. So I'm not going to go into great detail of each of these on every different node or virtual machine. However, I want you to just feel comfortable about how it works. So we've also got another window at the bottom which displays our log, and it is effectively doing a head of the log, so that the topmost entry is the latest log entry, which you can double click on and you get status. So it tells you what happened, and you can look here and find out what time it happened, etc., etc. On the first column, we actually have a data center entry. Now the data center is virtual, so this is your cluster. Okay, in this case there are 4 nodes, and it resides in a virtual data center. So the next column along actually has various tabs that allow you to change settings, make configuration changes, and also do summary, for instance, which is really quite useful. Summary tells you the state of the cluster. I've just decreased the size slightly. So it tells us the status is up and running, that all 4 nodes are online. Therefore, we do have a Core 8 situation. In other words, everything's fine. We've got 4 virtual machines, and they are all running. And we have no Linux containers, because I haven't built any yet. We will do, but haven't built any yet. And then you've got various tabs here which allow you to, as I say, configure and view different options. So the summary one's quite useful. The notes one is useful. You can actually put in here all sorts of information about this cluster that you can refer back to later if you forget some details. So that's cool. Then if we look at the next column, the sort of rows below data center, what we can actually see are the nodes. So these are the physical nodes. So we've got Trans Am, Mustang, and Cobra, was it, in my diagram? But you'll see I've added a new node as discussed earlier. And each of those can be expanded. Okay, so we'll see here that we can see on Charger we've got a virtual machine called Firebird. And if I select Firebird, then I again get a row of, or a column of different tabs that allow me to look at the hardware configuration, various options to do with this virtual machine, etc., etc., but including a summary. And the summary shows you that this machine actually only has, it's only got 2 gigabytes of memory. So no wonder it's struggling. But you can see here, and then you can actually see graphs of CPU utilization, memory utilization, network traffic, etc., etc. Okay. And then below that we can see storage. So local network is, I beg your pardon, that's actually the network. So it's showing us the state of the network. We can see storage. So Kukang is the name of a NFS server that I have, and local storage, and also local logical volume manager, which all of these things we will talk about in detail. So this is the basic interface, human interface, which is very nice. And you can do almost everything in here, but not quite. There are some things that you need to do on the command line. There is an incredibly powerful CLI interface, command line interface. And we will look at that, especially when we look at things like cluster management. So if, for instance, we had a split brain situation that we discussed earlier on, then you no longer have quorum. But what if you had a situation like this? We've got two nodes in one data center, 2 nodes in another data center. So the Charger and Cobra in one data center and Mustang and Trans Am in another. If Mustang and Trans Am go down, then Cobra and Charger can no longer continue because they do not have a majority vote. And you would look at the data center summary and you would see that this would be red and it would say quorate no. So we have a problem. So the only way to fix this, well, the best way is to get Mustang and Trans Am back, but it could be that you need to actually bring this cluster back up again. And to do that, on the command line, you can actually say, well, I don't expect 3 votes for my quorum, which this would be, 50% plus 1 is 3 in this case, so a majority vote would be 3. You could say, I only expect 2 votes, and then these guys could continue to operate. Okay. And interestingly, if you've set up high availability, if Mustang and Trans Am went down and you'd configured these VMs to be in the high availability mechanism, then after after you've changed the quorum requirement, these devices would then start up on Charger and Cobra. So this of course is assuming you have shared storage. Remember, if they're using local storage, then it's impossible for Barracuda. It would be impossible for Barracuda to start up on Cobra or Charger because they don't have access to its virtual disks. But if the storage, as it is in my example cluster, is shared, then they can. So that's all good. Okay, that concludes part 1. So you now have an overview of what Proxmox is and basically how it functions. So in the next video, we're going to install a cluster from scratch and create some virtual machines, migrate them around, and generally get a feeling for the web user interface. So I hope you enjoyed that video. If you did, please subscribe and click on like, because that helps get it out and about. And it also means you'll get informed when new videos come out. So thank you very much and see you in the next session. Bye.